A very fine morning, my dear students. Hope you all will be fine by the grace of God. Today we will discuss about new chapter, that is chapter number 5, towards green energy. It is the chapter number 5th of Science 2 Standard 10th. Students, in this session we will discuss about energy, use of energy, generation of electrical energy, thermal energy based on electrical power station, power plant based on nuclear energy, etc. Students, here also whatever portion or whatever content are omitted due to COVID problem, that I'll cancel out. So let us have a look on some slides, then we will start. Here you can see that different forms of energy are there, as mechanical energy, chemical energy, sound energy, light energy, electrical energy, nuclear energy. So we are using energy we need our basic things like food, shelter, clothing. Same way nowadays, energy is very essential for our daily routine. So without that, it is very difficult to survive. So we need these all types of the energy. Now we will see that for diverse type of work, diverse mean which is showing different varieties. For diverse type of work we need energy. This is in different form that already I have shown you. Let us see the next slide. Here the conversion of energy is there, how the electrical energy is changed to light energy, then electrical energy can be changed to heat energy. Same way sound energy can be changed to electrical energy. Solar energy can be changed to electrical energy. Electrical energy can be changed to mechanical energy. Chemical energy changed to heat energy. So these are the conversion of the energy. Now see children, if you think that what is energy, so what will be our answer? This boy is playing with the ball. So what is energy? Energy is the ability to do the work. So we can see here energy is the ability to do the work. Next, what are the different types of energy? So what are two main types? Potential energy and kinetic energy. So there are two main types of energy, potential energy and kinetic energy. Now children, we'll see next. What are the different forms of energy? So we'll see the different forms of energy are the muscular energy, mechanical energy, chemical energy, etc. Now here you can see the muscular energy. Here you can see the mechanical energy. In this figure you can see the chemical energy, how the food is getting digested. Here you can see the thermal energy. Here you can see the electrical energy. Here you can see the gravitational energy. So this way we can see the different forms of the energies are there. Children, let us start with the explanation now. We are going to start with this chapter. This is towards green energy. Now here children, this can you recall, and this all is cancelled. Now this also, here one make a list, that also is cancelled. Make a table, this also is cancelled. So we will see from here energy and use of energy. So in this we'll see that already I have explained you, I have introduced you that in modern time the energy become a primary need along with the food, clothing and shelter. And in diverse type of the work or different type of the work we need the energy is of different type that already I explained you. So we know that the energy can be converted from one form to the another form, that also I explained you, that example also I have shown you. Now here we can see that different methods are there to create the energy, to generate the energy. So let us see the generation of electrical energy. Here is the generation of electrical energy. So, in this we will see that most of the electric power plant are based on the principle of electromagnetic induction. Recently, you have studied in on, in the science one chapter that electromagnetic energy and Michael Faraday. This all you have studied recently. So let us see now that whenever the magnetic field around a conductor changes, a potential difference is generated across the conductor. So now what is the potential difference, that I'll explain you. So what is potential difference? The difference in the amount of the energy that charge carriers have between 2 points. So that is the potential difference. So the field around a conductor can be changed in two ways. What is the first way? That if a conductor is stationary means stable at one position, and the magnet is rotating, the field around the conductor will be change. And sometime if the magnet is stationary but the conductor is moving, then also the field around the conductor will be changed. So both in these both cases the potential difference is created across the conductor, and electric power generating machine are based on this principle, that is called the electric generator. So this point you have to underline, children. This you have to underline. So we'll see that such large generators are used in the commercial power generation plant, because we need the large amount of the energy, that is why they are used in the commercial power plants, and to rotate the turbine. So here the main thing is turbine, that I'll show you now what is turbine. And actually the turbine is the rotatory mechanical device that extract the energy from a fluid, which is converting it to a useful source of energy. So here we'll see that the main thing is based on moving or rotating the turbine. So what is turbine, that I'll show you now here in the pic. And when the turbine is rotating, the magnet in the generator also start generating the electricity. The turbine is having the blades. So when a flow of liquid or gas is directed on the blades of turbine, when that mean it is just that suppose it is water is thrown with a large amount of the force to the blade of turbine, then it start rotating. So because of that the kinetic energy is generated, and the whatever the kinetic energy flow start, that which generator is connected to the turbine, that start rotating, and due to that the electric current is formed, and this electric current is used for various purposes. So here we can see, children, here this is the turbine. Here you can see this nozzle is there, high velocity steam. This steam is put inside on the blades of the turbine, and these are the blades. So on the blade, this you can see this steam is falling. This is the shaft. Now what is the shaft? That is a handle like arrangement. Here you can see how the inside structure is there. This is the coil here. This is voltmeter to measure the potential difference. This is induced EMF. What is the EMF? That is electromotive force. So here the line of flux are there. What are the line of flux? What is the meaning of line of flux? Line of flux mean magnetic lines of force that are emerging from the north pole and terminating to the south pole. So this way we can see this is the arrangement whatever is made here. So this is the steam turbine and this is the electromotive magnetic induction is there, that already you have studied in science 1. Now this is schematic of electric generator. This diagram here the generation of the electrical energy is there. Now this method of electric energy generation can be represented as the flow chart. So to generate the electricity which is based on the principle of electromagnetic induction, we need a generator. So this point you have to underline. So to rotate the generator we need a turbine, and to drive the turbine we need an energy source, which is based on which type of the source is there. To rotate the turbine, that are different type of the sources, and that according to that the name of the station is given as thermal station, nuclear power plant, that way. So how the arrangement, how the flow chart is there, that proper energy source to run the turbine, and then turbine is rotating, then it gives the energy to generator, and generator is producing the electrical energy. So let us start with the thermal energy based electric power station. So here in this turbine is rotating using the steam. This point you have to underline. That means what is used here to rotate the turbine? Steam is used. Water is heated in a boiler, and using this thermal energy which is released due to burning of the coal. First of all they are burning the coal, then water is getting heated, and then due to that steam is formed and steam is rotating the turbine. Steam is at very high temperature generated. The energy in the steam drives the turbine, and due to this energy the turbine is moving. So the generator which is connected to the turbine rotates, and electrical energy is produced due to the rotation of turbine. Here the steam is further converted back to the water, so that this whatever the water is there, that can be used and reused, because the steam is again converted to the water, and the water is recirculated in the boiler. So that you can understand with this chart, children. This chart here you can see. See now. So here we can see fuel, what is used, that is coal. Then in the boiler the conversion of water to steam takes place. Then this steam is rotating the turbine. Turbine gives energy to the generator, and then electrical energy is produced. Further this water goes back and change to further this steam change to water, and further this water is recirculated. So this is the arrangement. This is the flow chart which is showing the generation of electrical energy using the thermal energy. Children, here we can see since the thermal energy is used here to generate the electrical energy, such power plant are called as thermal power plant. This you have to underline, because the heat energy is or the this water's steam energy, steam is used to generate the electric electricity. That is why these are known as the thermal power plant. In thermal power plant, the chemical energy in the coal is converted into electrical energy through the several steps. So that step we can see chemical energy in the coal, what is there, and this chemical energy changed to thermal energy. Further, this thermal energy is changed to kinetic energy in the form of steam. This kinetic energy rotates the turbine and then it changed to electrical energy. So this is energy transformation in the thermal power plant. Now children, this is the diagram for that. I'll show you animated figure so that you can understand in better way, but this is the diagram. I'll first make you understand here. Here we can see that here the fuel is there, then this, due to this fuel, the turbine, this is the turbine which is rotating, it gives energy to the generator. Here I'll show with the different color generator. So this is the turbine and this is the generator which moves and produces the electrical energy. Here whatever the vapor and hot air is there, that is cooling. This is known as cooling tower, and here the cooled water is filled. This water further goes and it, here you can see that further it goes and change to steam, and further you can use. Here the stack of the gases is there. Stack means together, all together the gases are collected here. So it is the schematic of the thermal power plant. So let us now first see this part is cancelled for you children. This full part is cancelled. Now children, I'll show you some animated video. So children, just watch the video, you can understand in better way. After this all everything I have explained you, no need of explanation, just watch the video. And after that, this already I have shown you, I explained also. Just see so that you can understand in better way. See how the this coil is rotating and how the Michael Faraday studied this all effect. Here you can see how the magnet is rotating. This is a stationary conductor. This magnet is rotating. That all I explained you. Here the magnet is stationary but the conductor is rotating. See both the cases. Both cases I taught you. Just I explained you. In one the magnet position is rotating, and second one the coil is the magnets are stable and the coil is rotating. Here how the turbine blades are working. This is turbine. How it is connected to electric generator. This is generator. You can see here how the structure of generator is there. This is energy source. You can see this is turbine. How the flow chart is there, that you can see here. Here the water is heated in boiler and using the thermal energy. See how it rotating. The generator connected to the turbine rotates and the electrical energy is produced. Here the steam is converted back into water and water is recirculated to the boiler. Fuel is used as coal. Boiler for the conversion. Here you can see that thermal energy is used here to generate the electrical energy. These are thermal power plant. You can see the structure. How the coal is used here, that you can see. Coal is as a fossil fuel. This coal is coming from the plants. So these plants die and the stored chemical energy changed to fossil fuel, that is coal. So the energy which come from coal, it is called chemical energy. Here steam is used to rotate the turbine due to some region that you can see here. It can be reused by condensing into water and it is adaptable to various conditions. You can see the structure here, how the steam is there, then boiler is there, turbine is there. This is thermal power station. This structure already is studied in your book. The steam is at very high temperature and pressure, due to that it creates the energy. The water in the cooling tower is circulated through the condenser. So thermal power generation is a major way of electricity generation. Let us see here. Here you can see the nuclear, electricity generation in the nuclear power plant. This I'll explain you now. First you see, then you can understand in better way. Here the nuclear energy is converted into thermal energy, and then thermal energy is converted to kinetic energy of the steam. Then kinetic energy is converted to kinetic energy of turbine. How the flow chart is there that you see. See this diagram, how from the uranium the electricity is uh, generated in the nuclear power plant. So children, now let us see our explanation part. So let us see now what are the problems. So due to this, what problems can arise? First is air pollution due to burning of the coal, and burning of the coal result in the emission of the gases like carbon dioxide, sulfur dioxide, nitrogen oxide, etc. Second is that along with the emission, what is there? Due to burning, the coal is also coming out, the soot is also coming out, soot particles are coming out in the atmosphere, so we can have the respiratory system problem or health problem also. So what is the soot? That is a black color powder. That is this soot is formed due to the unburned carbon particle. This part is cancelled. So reserves of the fuel which are used in this method that are limited, so we should be careful regarding the use of this, so that for the future also they will be there. Now we'll see power plant based on the nuclear energy. In the power plant based on nuclear energy, the steam turbine is used to rotate the generator. But here the energy released by the not by the coal but by the fission of nuclei of atom like uranium or plutonium. So what is the meaning of fission? Fission means breaking or splitting. So when the uranium 235 atom is splitting, then large amount of the energy is coming out. So it is used to generate the steam of high temperature and high pressure. The energy in the steam is rotating the turbine, and which in turns drives the generator and which produce the electricity. Here we can see the flow chart, children. Nuclear reactor for the nuclear fission system, for the steam generation from water. Then it steam is provided to turbine which is rotating due to high pressure. Then it due to the rotation of the this turbine, what will happen, children? Here that it drives the generator, and which in turn it will produce the electricity. So here you can see, children, that a system for the conversion of steam back into water, and here the fuel is used as uranium or plutonium. Now here we can see that here nuclear energy is converted into the thermal energy, and thermal energy is converted into kinetic energy of the steam. This kinetic energy of steam converted to kinetic energy which gives rotation to the turbine, and finally the kinetic energy of the turbine is converted into electrical energy. So step by step information we can see here, children. This is nuclear energy which generated from the uranium. Then it changed to thermal energy. Thermal energy rotate here it in the form of kinetic energy which is present in the steam. It rotates the turbine and which drives the generator, and the electric energy is produced. Now children, here we can see that whenever the neutron is bombarded on the atom of uranium 235, it absorbs the neutron and changes to isotope as uranium 236. Isotope already you have studied. So in A standard I already studied. Now uranium 236 is being extremely unstable. It convert to into the barium and krypton through a process of fission, which release the three neutrons. Just imagine one neutron changed to uranium 235 into 2 uranium 236, an isotope. Then this three neutron further generate the in this they process the and cause the further fission of three uranium 235. One is converting one atom of uranium 235 to 236. So three neutron will convert three uranium atoms to they will do the fission here, and large amount of energy will be released here. So here we'll see, children, the neutrons which are released in this uh, reactions. The more energy through the fission, and the more uh, fission of the more uranium nuclei, because but natural that first time one uranium nuclei was bombarded with a neutron. Here three uranium atoms are bombarded with three neutron. So here in this process of fission of uranium 235 atoms continues, and this forms a chain reaction. That means this further this three neutron will bombarded, then again the from the three again more will be given out, and this further this will go on, and this will form a chain reaction. So in nuclear power plant, a control chain reaction which is resulting into the thermal energy, and which is used to generate the electrical energy. So here you can see, children, this is very important. This part is cancelled for you, but this is very important. This you have to study. So children, here I am ending my lecture, and hope you might have understood what I have explained you. Write the important point, learn it by heart. Just read each and every sentence and try to understand. Here one more diagram is there that already I have shown you, but you can see again here, children, this diagram I have shown you in the animated picture, schematic of nuclear power plant. This already I have shown you. Two more sentences are there, so let me finish this so that this topic will be over for you. Here a nuclear power plant does not use the fossil fuel like the coal, so therefore problem like the air pollution do not arise. But natural, if coal is not used, so air pollution will not be there. And if sufficient nuclear fuel is available, then this can be a good source of the electrical energy. This is the advantage. This part is the advantage. So this is the advantage. Now these are the problems, so these are disadvantages. These are disadvantages. Now we'll see here. There's first the product of after fission of the nuclear fuel, they are also radioactive, so they emit the harmful radiation. So it is a big problem to dispose this nuclear waste, because these are the nuclear waste. Second, an accident also may occur in the nuclear power plant, and that may prove to fatal. So these are two disadvantages. This part is cancelled for you. So here we will end our lecture, then further we will proceed with the next lecture. So thank you, children. Learn what I told you.